Yeah, I'm from the South Australian Seed Conservation Centre, and I work with Dan Duval and Tai T. So it's a small group of us. We're in the Botanic Gardens of Adelaide in the Goodman building, which is sort of between the Wine Centre and the Herbarium. And our focus of... Can you hear me? Is that getting out to the back? Oh. Is that better? A little bit better? Maybe I'll just put it on my shirt. Okay. Yeah. So the focus of our program is conservation of seeds ex situ. So we have a seed bank up there, and the focus is threatened flora. So we travel the state collecting seeds from threatened flora and putting it in the seed bank. But I'm not going to talk about that today. I'm going to talk about some other projects that we've been working with restoration groups and using seed biology to help outcomes. So I'm just going to talk through some examples of things we've done. This example is Triodia scariosa. Sometimes plant species that are actually key species in ecosystems are difficult to put back in restoration, and this can be a number of reasons for this. But this Murray-Mallee lap group came to us saying that they've been collecting Triodia and spreading it out and having trouble without any germination, or could we help and have a look at what was going on in the seeds. I'll just point out in the corner that little map. This is taken from our website, Seeds of South Australia, and that colour coding is just regional threat status that we've put up there, so it's by IBRA sub-region. And so this is showing that this is quite a common plant, yet it was struggling to be used in restoration. So they brought the seeds in that they've been collecting, and we had a look in the lab, and the first thing we found was that they weren't collecting seeds, they were collecting seed heads, the seeds that are either not developed or, and you think it's very obvious that you're collecting seed, but it's not always obvious. And so what we did was ask them to recollect later when the seeds were more developed. We photographed the seeds, we put all this on our website, so everyone now can go to that website and see what they should be collecting. And so this is the actual grain, the caryopsis. Without that part, nothing's going to happen. And that also shows a cut test. We then went on to do germination testing and found that it didn't germinate very easily and required some fire cues such as dry heat and smoke before we got really good germination. And also germinated best in the summer conditions, being a summer C4 plant. So it's a fire-responsive, summer-growing species. And so we went on then to propagate hundreds of plants in the Mount Lofty nursery, and this was taken a couple of years ago, have now been growing at site near Baccara for the Murray-Mallee Restoration Project. So that was a fairly common species. I'm now going to talk about another project with the Murray-Darling Basin, NRM, that we've been doing with Kylie Moritz. And this is looking at Prostanthera eurybrioides, which is a nationally endangered species. So the advantage of working with this is ideally conservation of these highly threatened species are in situ as well as ex situ. It's preferable to have things living in the environment. So they wanted to bulk up numbers. They'd been collecting seed. They wanted to bulk up numbers and plant out more Prostanthera. Again, the seed collections came in and we analysed them in the lab. In this case, I've shown X-rays. So we've got a little X-ray machine, so that's seed X-ray next to actual just a photo of the seed. And we found that the viability was very poor for a lot of their collections, in that even though the seeds look good when you collect them, they're actually empty inside through a number of different development problems. Also, by comparing the X-ray and the seed, we could clearly see that the light pale seeds were never viable. Anything with damage to that mericarp plug were never viable, and it was the darker seeds that were more likely, not always viable, but more likely to be viable. So from the 17,000 seeds they collected, there was only about 1,500 that were actually usable. So we recollected again in 2016, which was a good year, and got 20,000 viable seeds off of 3 populations. So we've now used those seeds for banking, so now we've got good ex situ conservation for that species in the bank. and we've also been able to germinate plants. Once again, this also had some germination issues. Phil Ainsley, who was the manager of our group previously, has done some work on that. That Mericarp plug that you can see in the tester has to sort of crack open before it will germinate. You can do that physically, or you can do treatments such as we found a combination of heat, dry heat, hydrogen peroxide and smoke water induced high levels of germination. And we've now grown over 2,000 plants for planting back at Monarto. This is the Monarto mint bush. So Garnier Trip is another one. We're working on this with AMLR NRM for restoration down at Deep Creek with Randall Johnson. We've also had problems with Garniers and also Lepidospermas and other members of Cyperaceae. The viable seeds actually hang out of the seed heads early on, so that picture with the fruits hanging out there, that's what you want to see. You want to see this dark, shiny seed that's hanging out of the seed head. There are other brown seeds, so you can see up the top there it's a brown seed collection that they are retained in the heads, so often they're the ones collected because they're always there. They actually had very limited viability. So that's a cut test, so we spend a lot of time looking at seeds and cutting them open and torturing them in various different ways. So that cut test shows underneath the black ones is filled seed, and versus underneath the brown ones you've got empty seed or partially developed seed. And this also has got germination issues. I'm working on that at the moment. I've got up to about 50% germination on the Garnier. That black shiny seed, you can see that there's an oiliness to it, and I think there's inhibitors in the seed coat, and I've found that heat treatment, peroxide treatment and leaching treatments will reduce dormancy. Now, these are the most difficult, in my experience, the woody drupes. So I'm working on these as well for AMLR. So Pesunia eremophila and Astroloma cosmostephoides has just changed names. It's a stenanthinum or something now. So these, all I can say is if you can get the seed out of the woody endocarp, it will germinate reasonably easily. But that process is pretty tedious, but we can do it. It's a matter of cracking them out. And I've propagated quite a few Eremophila deserti for a France scrub. Got quite a number of Pesunia up. Pesunia in the middle, actually, if it's weathered, it has a fracture line, which is very easy just to open up then. And then germination happens fairly quickly. And Astroloma as well. So sometimes these species are dominant in the landscape, yet their plants are not available. They're difficult through cuttings and through seed. So it's important to be able to, they're very key species for habitat function. So in summary, really, just that the restoration of key species or highly threatened species I think we've made some advances. We've put all this information on our website, so it's available freely to the public. It's enabled us, the collaborations have enabled us to really answer some research questions. Usually we routine test everything, but we don't have the time to actually really get detailed germination information, and these projects have really allowed us to make some progress there. So that's a website address, and we have a young volunteer who just made an Instagram. He's doing it, so it's good. But this is just a quick example of the website. So we've got these little maps showing the threat status. We have photos of plants and seeds, a lot of seed detail, when to collect, how to collect, what to collect, how to clean, and a list of germination experiments, as well as descriptions of fruits and flowers and other information. So yeah, we're up to about, we've got information for nearly 3,000 species now, but we're still backloading that up. Thank you.